A study reports that 33% of all people own dogs. Suppose that 2 people are chosen at random from this population. Are the events dependent or independent? So to decide here, generally the rule is if the occurrence of one event does not affect the probability of the next, then they're independent, otherwise they're dependent. The situation here, since it's more like an empirical probability where we don't know the entire sample space because this population is very large, all we can really do is just assume independence because it's a large population. So these are independent events because the events derive from a large population. And one thing that I see students trying to do in situations like this, if they want the probability that both own dogs, what I see students attempting to do incorrectly, and I'll put this in red because it's wrong, is take 0.33 times 0.32 so that you're reducing the second probability. But because they say 33% is the probability that someone owns a dog, so that's the first, and then they want to reduce the second. But the problem is, this is a reduction of 0.01. 0.01 is 1 out of 100. So what you're assuming is your population is either 100 and one person is chosen and taken out. Well, actually, that's exactly what you're doing. So you're assuming that your population is exactly 100, but you don't know the population size. It's a very large population. You don't know what that size is. It's not told to you. So you actually don't know how to reduce that second number anyway. And even if you did, the thing is, when you reduce it, if the population size is like 340 million, when you reduce it by 1, that doesn't really make a whole lot of difference to the accuracy that we take our probabilities. It generally doesn't make any difference whatsoever. So don't run into this kind of trap thinking that you have to reduce it some way. If the events come from a large population, then you can assume independence, which makes your probability easier to do. Because the probability that they both own dogs, so the first person owns a dog and the second person owns a dog, if 33% of people own dogs, you can interpret that percentage as a probability. That's okay. So you can say the probability that the first person owns a dog is 0.33 and the second person owns a dog is 0.33 because we're assuming independence. These are equal to each other. So then what we would do is multiply those. So 0.33 times 0.33. And of course you could use 0.33 to the second power. That's fine. Either way you get 0.109.